Okay, we are live now. Back to English, back to Kubernetes, back to Hetzner cloud deployments, back to magic stuff. Max will tell us today in step 4 or part 4 of the workshop we are having. So looking forward to learn something new today. And Max, over to you.
Yeah, I just noticed that my video is disabled. I think when I start screen sharing, then my video is disabled automatically. Then I have to enable it again. All right, yeah, welcome everybody. Today we will continue what we started the last few sessions. Last week we deployed the Cloud Controller Manager. If you remember this one, the Cloud Controller Manager, which is responsible to organize all the IP assigning stuff that is related to our cloud provider, like the external IPs and the external IPs for our nodes and the IP addresses for load balancer services. Last week we created a load balancer, and this way we were able to access a website running in our cluster by just entering the IP address in our browser, which was quite a nice first step to expose services to the internet. And last week we moved really fast in the end, and it was a bit hacky because we needed to edit the service, the load balancer service, to add the correct annotation. And this week we want to clean this up a little bit. So what I planned to do, I want to show you for a second, was to this is the documentation for the load balancer stuff with Hetzner. And at the bottom, there's an explanation about cluster-wide defaults, where you can set some environment variables for your load balancer service. And I tried this yesterday because I wanted to do this with you today. And I was confused why it wasn't working. And after a while, I noticed that in the repository, there is a change log, and those are listed on unreleased. So we can't define any default values right now. So for the time being, we have to add those annotations to each load balancer we are creating, which is not too bad. We just have to know that we have to do it.
Or
Niklas, you want to say something?
Build the image by our own and use it.
That's also an option, yeah.
Because it's only a Docker image, so right? It's only changing it in the deployment, and then we can use it.
Yeah, that would also an option. Yeah. So we are not going to use those variables now. So we are going to start to look into a little bit of another direction. One thing I showed you last time was that in the end we had a load balancer in this list. And I explained if we would expose every website the way we did last week, then we would need an additional load balancer for every website we expose. And with each load balancer costing around €6 per month, this adds up really fast. Like for 10 websites, you suddenly pay €60, and that's not really nice. And it's possible to do this all with one load balancer. So Kubernetes has a concept, it's called ingress, and I'm going to open the documentation for this. So in the upstream Kubernetes documentation, there's this is the overview page for ingresses, but there are a lot of more stuff documented about it. And the whole idea of the ingress resource in Kubernetes is that if you want to expose a website on a specific host, a specific path with some configuration, you can create an ingress resource, just like you create a pod or a deployment or a service, which we did last week. You can create an ingress, and this ingress includes configuration for the endpoint you want to expose. And then in addition to this, you run an ingress controller in your cluster, which will monitor the changes in those ingress objects. And according to those configuration in those ingress objects, it will configure itself to serve those websites to the public. And you are free to choose the ingress controller you want to. So the Kubernetes does not force you to use one specific ingress controller. There are a few well-known ingress controllers, but in theory, you could also write your own. I think the most common one is the nginx ingress controller. It's it's using the nginx web server as a reverse proxy, and nginx as a reverse proxy is beta tested for, I think, decades now, and so it's one option to use, which we will do today. But there are other options as well. For example, there's traffic, there is an ingress controller for HA proxy. Even if you use a hardware appliance like F5 for load balancing, you can use an ingress controller for this, which will run in your cluster and then reconfigure the hardware appliance according to your ingress objects. So there is a wide variety of ingress controllers, and you have to choose what suits you best. For today, we will use the ingress nginx controller, and it's a little bit tricky because there are two ingress nginx controllers. One is developed upstream from nginx itself, and one is developed by the Kubernetes project. And I think the more common one is the one from Kubernetes. I think especially it's the older one, so more people are using it already. And the same for us. We will use the ingress nginx controller. There's some documentation, how to deploy it, how to configure it. And that's what we will do. We will click here, deployment. And we are going to use Helm to install it. So there's a lot of interesting documentation. So if you are new to it and you want to deploy it, it's probably sensible to read this. We are going to jump ahead to Helm. And we will talk about Helm in a minute, like what it is and what it does and why we use it. First, let's go back to our cluster and create a new namespace. Today I got a new keyboard, so I will make a lot of mistakes while typing because my muscle memory is totally off now. We will call this namespace ingress. So now if we look at our namespaces, we have those default namespaces, which exist from the beginning. And then we have the new one, ingress. I'm switching to it, so all my commands now default to this namespace. And then, let's talk a little bit about Helm. Helm is a package manager for Kubernetes. So there's also a website for it to do the full life cycle of your containers and everything. And the last few times we used for just YAML files, for example, in here for the Cloud Controller Manager, we just did something like kubectl apply and then provided a file. And then in this file, there is plain YAML. So this is okay in the beginning, but the more you work with Kubernetes, the more YAML code you write. And it's hard to reuse this code because every deploy 5 different, you can see there's quite a bit of boiler. Helm uses the GitHub repository. Check out the Helm chart, or Helm or something like that. And here we have a Helm chart for ingress nginx. And a minute ago, I said we are going to template YAML files. So maybe let's look in the templates directory. Now we see a bunch of YAML files, quite the list, and maybe look for deployment, controller deployment. Now it looks similar to the YAML file we had last week. There's a kind, there's metadata labels. And down here, search, we also have the containers in our pod. But in addition to this plain YAML code, we have all those curly brackets. And each time you see a double curly bracket, that's part of the Go templating language, which tells Helm, or the templating engine, please don't print this as YAML, instead template this. And there's an if condition in here, like only do this if some value is if some variable has the value deployment, and then for the labels, there's one variable including the labels, and then this variable is reused across the chart. And this makes it quite easy to only provide templated based on this. So times the values, we can see those. Basically, those are the settings you can apply to a Helm chart. Variable depends on the Helm chart. Some are more common, for example, and it's because often we don't need to, so we only have to change one or two variables. So let's look into this in action, then I think it's easier to understand. So, all right, let's maybe create a new directory here. Let's call it Helm. And we are already in our ingress namespace. There are no pods. Ingress nginx. So let's install this. Maybe while this is running, we can open a second terminal and let's do something different. So instead of Helm install, we make Helm template, ingress nginx, ingress. And then it does not directly install it in our cluster. Instead, it will print the rendered template to us. And that's quite a lot. So maybe let's pipe this into less. And then we see now that there are, instead of this variable, there's a bunch of labels. And they are the same across the whole output. And here we have a bunch of rules, what our controller is allowed to do. Then here we have a service. That's something we already know, right? So apparently it's some controller service webhook. Then we have the controller deployment, again with the same labels. And down here we have the container. All right, so that's what Helm does. It renders all this YAML code, and then it applies this to the cluster. And our install command is done by now, which is nice. It gives us some help output, which we can ignore for now. Then we can see that now we have pods in our cluster, or actually we have one in this namespace. And we can also check for services. Then we can see we have two new services. One is the controller itself, and one is controller admission, which we will completely ignore. Maybe, I don't know, in a few months, when we are all very comfortable with Kubernetes, then we can talk about admission controllers. But for now, it's only, for us, it's interesting, this controller. And that's the same kind of service which we created last week by running something like kubectl, expose, simple, nginx type, load balancer, something like this we did last week, and then we got a load balancer. And just in the same way, the external IP stays in pending. So let's do a describe on the service. And just like last week, it tells us that there is some annotation missing. So last week, we did kubectl edit service and then modified it on the fly. But now we are using the same chart and we don't want to change it after the installation. We want to configure it from the beginning. So what we can do is to override those values. So maybe let's create a YAML file. call it ingress YAML. We are completely free to choose whatever we want to choose here. And then let's look into the chart. Can look into our values file. And then we can search for annotations because we want to change the annotations of the service. And the nginx controller is quite the complex software, so it has a lot of options. So for smaller charts, often you have more like 20 options and not 500. And so in the beginning, you will need a few minutes to search for the right option you want to change. But down here in servers, it's already enabled, but the annotation dictionary is empty. So it's a little bit hard to see here, but the service key is actually part of the controller dictionary. So what we will do is, I don't have to open this in VI. We have Visual Code here, right? So let's open this here. This makes copy and pasting a little bit easier. So we define the controller key. In there, we have service, and then we have annotations. And the annotation we did last week was this one, load balancer, Hetzner Cloud, location, Falkenstein 1, because our Kubernetes cluster is also running in Falkenstein. Now this way, we can change all the settings. This feels like the wrong amount of spaces here. Yeah, right, like this. And yeah, let's change a few more things. So if you remember last week when we had this load balancer, it had a very weird name here. It was like just a bunch of numbers. Let's give it a better name. Can use an annotation for this. And to figure out what annotations we can use, we can actually go here to the Hetzner Cloud Controller Manager. I think in docs, then load balancers. And here is, no, it's not. It's funny, it's not listed here. Here, a list of available annotations can be found on package go dev.
Mostly they are also on the official documentation, which annotations.
Okay.
Yes.
Okay.
Sorry, wrong topic. Okay, no, okay. I was thinking about the nginx annotations.
All right, yeah.
Yeah.
And for Hetzner, we have to look a bit in the source code, or not directly in the source code. It's a code of it's a documentation of the source code. That's the right word. And here we have an explanation what annotations exist. And one of those, for example, is the name. And yeah, what we will also set is, I think, disable private ingress and use private IP. So this one we will disable and this one we will enable. I will explain what those options do after we created it, because it's a bit easier to see when I can show it to you instead of just explaining it.
Short question. Is it also possible on Hetzner that you can set the IP directly? So an IPv4 address, and you will get assigned to it. So from the space from them. So
interesting.
Because on hyperscaler, it's possible to do that.
I don't think so, but I'm not exactly sure. Looking at this here, it doesn't look like it, but it wouldn't be an annotation, right? We would directly set the spec field for the IP address.
No, sometimes, no, you're right. It's the spec field. You would set it in the spec field. I remember on that. Okay.
So, but I'm not sure if they support this, but we should maybe try this out later or another time, because this would be interesting. If you don't want to lose a public IP address, stick to a specific one.
Interesting. Why can you set a cookie? Because I thought it would be in hardware load balancer, not in.
It's
layer 7 load balancer.
no, it's we will now use it as a TCP load balancer, but it's possible to use it as an HTTP load balancer.
Ah, okay, cool.
So if we create a new one, we can select the protocol. We can even terminate SSL directly at the load balancer.
Oh, that's nice.
But what we will do today is use it as a TCP load balancer. And if we use it as an HTTP load balancer, then we can also enable proxy protocol to get forwarded the client IP and stuff like this. All right. More annotations. So let's set those settings for now. And when we go back here to this, I'm now back in the ingress nginx values YAML, and we noticed that we had only one pod running for the controller, and it would be nice to increase the replica count to 2. So if one of our nodes fails, there's another controller still running. So let's do this. Let's set it to 2. Okay. And then now we already installed the ingress controller. We can check this with Helm list. And then we can see that in our current namespace, we already have this release. It's in the state deployed. So now we want to update this with our new settings. And we can use Helm for this again. Helm upgrade. And then we pass this values file, which in our case is called ingress YAML. Then we pass the release name, which we already used earlier, which we can see here. And then we have to tell Helm again which chart to use. I would love it if it was able to extract this from the existing chart from the installed release, but the installed release has no knowledge about its source. So there's no way to extract the which chart you want to use. So we have to tell him which one to use. So if I press enter now, then those changes would be just applied. And there is a nice add-on for Helm. So Helm has a plugin system, which is called Helm diff. It's available on GitHub. And if you are working with Helm, I strongly recommend to use this. It's quite easy to install. Just Helm plugin install and then the repository. And it allows us to, instead of Helm upgrade, to run Helm diff upgrade. And then it shows us the diff instead of applying it. And that's quite nice.
Short question.
Sorry? Yeah.
But Helm diff isn't directly supported, right? So it's an extra plugin.
Yeah, it's just what I showed here. GitHub. You have to install it first as a plugin. Yeah. I'm kind of waiting until it is an official feature, because I think everyone who uses Helm is using Helm diff, but I'm not sure if they plan to include it or not. And yeah, it shows that what it would change. So for example, in the controller deployment, it will increase the replica count to 2. And down here, it will add those annotations to the service. And down here, it will also create something called a pod disruption budget. So that's interesting, because we didn't tell it to do anything with a pod disruption budget, right? We only did those changes. So in the chart somewhere, there is some template which checks the amount of replicas. And if it's more than 1, then it creates a pod disruption budget. That's what I guess. So let's look into the chart again. It should be
in the template of the pod disruption budget mostly, or in the helpers TPL.
Here is the pod disruption budget.
Sorry, could you explain what a pod disruption budget
Yeah,
is?
yeah, definitely. I will do this in a second. Yeah.
Ah, there's it. The first condition. It's like.
Yeah, this one, right? No, it's for the auto scaling. It has to be at the back here.
It's
If
an
it's
the
so
order is an or, so it should be when
here's an
auto-scaling is
or.
enabled. That's the part that I don't like at all. When you write complex conditions, it's not a complex condition, but if you need to read a lot of templates, it's hard to guess it.
But I think it comes down to.
Explain what the line is doing?
Yeah.
Okay.
You go ahead, Niklas.
Okay, so we're starting first with an if, and the first braces are currently condition the first true value of an OR, and the second condition of the braces currently the second value. And these both values will be compared, and after that, the final Boolean result will come out. So, and in the first one, it's an AND, so it will be conducted if when auto-scaling enabled has the value true and greater than. So there's also an equal in Klammern. In braces, it's also first the and it's greater than. So first we'll check the minimal replicas that are greater than 1, so that you have at least defined for auto-scaling a minimal variable set of replicas. And then it will check also if auto-scaling is enabled. So when no auto-scaling is enabled at all, it will use the second value from the replica count.
So this is
because
like it's their own way of describing conditionals in their language.
If you Google Max Pro, you go look for SPRIG functions.
How is it written?
SPRIG. SPRIG. Yeah, that's true. This is currently the templating language that uses Helm. And these are built-in functions by the SPRIG language template, and there's an OR for that reason.
Because from a user perspective, this is like I break my fingers when typing that.
It's not intuitive. It's like if you read it a lot of times, it's then you currently.
Yeah, from a computer's perspective, or like the small pocket edition of your calculator back in school, it makes sense. It's easier to interpret.
Yeah, mostly probably some background about the templating is that currently the whole template language uses Go template, because also Helm is written in Golang, and they're using this SPRIG function library as extension to do some more advanced features, because Go template doesn't have an or something like that. You can use a range, you can use an if, but nothing like comparison operators or something like that. So this is the reason why it's working currently. Yeah, but let's come to the topic what the pod disruption budget does probably.
Yeah,
it's more interesting.
So if we look at our diff here, there's a bunch of labels which we can ignore, and then it says min available 1, and this tells Kubernetes every pod which matches those rules, from those pods there always has to be 1 available. Always. That's a strict condition we tell Kubernetes to take care of. So if Kubernetes for some reason decides to reschedule some of those pods to different nodes when it wants to change stuff, and then it will always make sure not to kill too many of those at once. So if you have 5 instances of a pod, it will never terminate all 5. It will only terminate 4. And then if one of those is available again, it will terminate the last one as well. But there will be always 1 available. This, of course, only works for cases where Kubernetes does this as an active choice, like we are draining a node, which means we remove all running pods from a node. Then Kubernetes can do this as an active decision to terminate all pods on this node. If instead this node just crashes, then those pods are gone. So Kubernetes can't guarantee the availability of at least one pod in this case. But for all automated scheduling for everything, Kubernetes will, it will take care of our rules here. And we can use fixed values here, like minimum available 1. We could also choose values like at least 30% of our pod needs to be available, or at most one pod is allowed to be unavailable. It depends a little bit on the application, how strict you have to be about the availability. If you have 20 pods and high load on those, then you usually don't want Kubernetes to terminate 19 of those at the same time. It's more like you want to tell Kubernetes always have 60% of it running, but you are allowed to terminate the rest. And if it needs to recreate all pods after another, then it will only do it in small batches to always make sure this 60% rule stays true.
Yeah, mostly the other case that can happen is like when you have a lot of pods running on one node in Kubernetes, and currently the node runs out of memory or out of disk. So typically then an event in Kubernetes will happen that calls that the pod gets evicted automatically to a new node, because that comes from the quality of service. And with setting a pod disruption budget, we can ensure that at least one ingress controller will stay all the time over, so that every application gets traffic on it. Because when we don't have any ingress controller running anymore, we can't reach the cluster from outside over HTTP as the user mostly. Yeah.
And those kinds of things about Kubernetes are those topics you need to learn as for the day 2 operation. Like, it's easy to get started to deploy a few things, but then you need stuff like pod disruption budgets to really tell Kubernetes what to do, to be sure that it does what you want. All right, so we displayed our diff. Now let's really upgrade.
There's also a true site that was founded by Henning Jacobs where Kubernetes failure stories are listed when people get outages in Kubernetes. It's KS. And there are a lot of various stuff.
This one, Kubernetes as fuck, I guess.
No, F was something different.
Okay. For me, it always reads like Kubernetes as fuck. I mean, the domain is probably something different, but in this case, I read it like this. All right, so let's check our service again. And it now has a public IP address available, which is nice because now we set this location and now our cloud controller manager was able to create it. And if we do a kubectl describe, then we can see now the error is still here, but the error is now old. There are now newer messages, and those were successful. It ensured our load balancer with our cloud provider. And here at the top, we see our now new annotations. One of them was that we wanted to set a name. Let's go to the dashboard and display our load balancers. And now we see this name is used here. It's now called ingress, which is more readable than just a bunch of numbers. And yeah, it's still those health checks. The Hetzner now sends some TCP connections to our ingress controller. And if those are successful, then it changes to green here, which just happened now. So we set 2 more annotations. One of them is use private IP. If we don't use it, then the load balancer will send the traffic to the public IP addresses of our nodes, which is okay. It's not bad. It's okay. But what we can do is to use the internal IP addresses, because our load balancer also has a private IP address here. And we all have this in our private network, which we created with Terraform in the beginning. We have all our servers in here, but now we also have this load balancer in here. And now it will send the traffic over the private network to our nodes, which, when it's possible, I consider this nice to have. Definitely doesn't hurt. And if you do it like this, then you are able to apply a little bit more strict firewalling on your public IP addresses, for example, because those nodes don't need to be accessible from the public IP address anymore now, because the traffic goes through the internal network. All right, yeah, so here we can see as well the ingress is in there. And we can also see a bunch of routes which are created by the Cloud Controller Manager, which is for each node in our cluster, there's a new route created, which tells the rest of the cluster which IP addresses are used on which node. But it's a little bit more deep dive into Kubernetes networking if we start here. So back to our load balancer. It's now healthy, it's green. We can see it has both of our agents as a backend, and it has services for port 80 and 443, so for HTTP and HTTPS. So this sounds a lot like we can copy our IP address and visit it in our browser. And we can. So it's a little bit boring. We just get the 404 from nginx, because right now we have nginx running as a reverse proxy, but there's no backend behind it which would respond to any traffic. So the ingress controller, or the nginx ingress controller, has a concept of a default backend. Let's go to our values. Which is disabled by default, which you can see here. So let's just try to enable it.
Ah, this changed.
Yeah. In I don't know, a few weeks or months ago, they changed this. Okay. Which was a little bit surprising.
A lot of stuff were really surprising in the nginx ingress.
Yeah.
So it's like when I remembered when they removed the support for TCP load balancing and UDP load balancing. It was an interesting time.
So let's do the diff again. And now it's a bunch of more stuff. Let's scroll to the top. So here we have our controller deployment. And there's only one line changed. So in our controller container, there's one additional option passed to our actual ingress controller, which basically configures the default backend for our reverse proxy. And then further down, we create a service account again, which we will ignore. Niklas today asked me via chat if we can do a little bit of a session about service accounts and permissions in the cluster. And I think we should definitely do this at some point, maybe next week or another one. I guess we will talk about this after the stream a bit. And then we see this new deployment. It's ingress, nginx default backend. It's a deployment. Again, all our labels, but it's, here, our container. And it now uses a different image than the controller. It uses this default backend image. So yeah. And all this code just based on us setting this to true, which is a lot nicer than writing all this code ourselves. Let's apply this. Depending on the Helm chart and depending on how fast your cluster is, it can take a few seconds. So now let's check this kubectl get pods. Now we see we have our controller, which to my surprise is, it's all right. We are now seeing kind of the rollover of our deployment, because we changed the configuration of our ingress controller, and it can't change this in place. So it's creating new pods with this new configuration. You can see those here, 23 seconds old. This one, for example, is one of the new ones. And when this one is ready, it starts terminating the old ones. And for example, in this situation right now, our pod disruption budget is also there to ensure that always one of them is available. But I think Kubernetes, in this case, Kubernetes would also do this without the pod disruption budget, I think, but it definitely doesn't hurt. So now
I have a question. It was a little bit too fast for me now. What is the expected state we want to achieve with all the settings?
The goal is to have now 2 nginx ingress controllers. Therefore, we set the replica count to 2.
Okay.
Those are the 2 controllers. That's nginx reverse proxy, and it's quite the standard configuration to just take traffic and forward it to some backend. And in addition to that, we want to forward all traffic that does not match a better backend to be forwarded to this default backend. And the Helm chart allows us to achieve this by just setting default backend to true. Then the chart will take care of creating this additional pod and to configure those reverse proxies to forward the traffic there by default.
So right now I basically have 2 reverse proxies up front, load balanced, and the backend is like the default backend which is running and handles all the stuff which is incoming. And if I would probably overload one of the pods,
so it's the default page. It could be also the maintenance page or something like that. So if the URL is not matched, it's like it make more sense if you go to the browser and currently now refresh the site, and you can see the difference right now. We got not in form 4, we get now the result of the default backend.
Yeah, I think I misunderstood reverse proxy. It totally makes sense. If we describe it more like putting up a running 404 error message or like a maintenance mode website, then you have something up front, and in the backend it doesn't matter which type of pod is running. You always have something visible, and your users will see, oh, they have a maintenance window planned or something else. Yeah. I did that for this course as well, like putting an nginx proxy up front, because when you're building the Docker image, users would say, hey, the website is down. I said, no, the website is not down. Okay, please go on.
Understood. Right. Maybe a short overview of which way our traffic goes right now. It comes from our browser. It goes to the load balancer as a service from Hetzner. From there, it goes to one of our nodes, which one is random. And last time, the next step was this, that it went to our service. But this time, instead, I think it kind of goes to our first service, the load balancer service. And the service is implemented in IP tables again, so that's why I put it in brackets, because it's not something that really exists. From there, it goes to our ingress controller, so one of those 2 pods. And then the ingress controller forwards this again to our default backend pod. And there's a little bit more in between. Like this service ensures that at first it has to go to the correct node where actually an ingress controller is running. And the same happens over here, because there's also a service for the default backend. And then it could be that it goes to the node that runs the default backend pod. But because this isn't complicated enough yet, this service actually isn't really used at this point. So we can scratch this again. So the ingress controller, the code of it looks at the service and checks which backends are in the service, and then configures itself to use those backends directly without the way over the service. In reality, this is most of the time not important, but if something does not work, it gets important. So what do I mean with services and endpoints here? Let's look at our services. So we have a new service for 6 minutes now, ingress nginx default backend. Let's look what it looks like. And in here we have an endpoint, this IP address. And if we do kubectl get pods minus output white, then you can see that this is the IP address of our default backend pod. And what the controller, which is running here, does is it talks to the Kubernetes API, requests the service, parses the endpoints in here, and applies this to its own configuration. Now I can try to improvise a bit and look into one of those controllers. So I'm now have a shell in one of those controllers, one of our proxies, and we can go to our nginx configuration, which is over here. And I hope it's still in the way that it's in here. And maybe let's, not sure, let's look for default backend maybe. No, it's not here. We can probably search for this IP address we had over here. So that happens when I improvise. All right, so this is our ingress or nginx configuration. And let's search for it. It's also not here, that's sad. It's a little bit tricky because
a default conf or something like that. So let's say using it like by. No, I mean a separate file. So in
okay.
etc nginx default conf something like that, or confd probably.
I'm not sure because part of the config is evaluated in Lua script on.
Okay.
While it's running. So I think if we create an additional ingress, this one should end up there in the configuration file. Could be that in some way the default backend is handled a little bit different. I'm not sure.
But what we can do is to check the logs.
Yeah, we can do that.
And doing a request so that we can see what's happening mostly on a controller.
Right. Let me change this. So it's a little bit tricky because it could, and we could check the logs of the backend as well, right?
Yeah, probably it depends on what you want to see, literally. So, do you know the tool kubetail?
Yes, but there are a few tools for this, but usually I don't use any of it. But we could also kubectl get pod show labels, and then
okay, yeah.
kubectl. So with kubectl logs, we don't have to define a specific pod name. We can also define a label selector. And both our controllers have this label app Kubernetes IO component controller. So let's look into those logs. And now we get the logs of both controller pods at the same time. And interesting. I think the logging for the default backend is disabled by default. So I think it's
okay, so that you don't spam your logs. Okay.
Yeah. Okay. We can check those logs. And
I already started the while loop with the curl thing.
And I think the default backend itself is also logging nothing. All right, in a few minutes, we will deploy an additional backend, and then I think we will see some logged queries. Then we can come back to this. So as a first thing now, I will create a DNS entry for this IP address. Give me a second. So just imagine some background music playing. Or if anyone has any news to share, now would be the perfect time.
Any news? News time. Next week we have GitLab 13.9 on Monday. I need to check out what's coming, but it will be the best release ever, as always.
Then we need to deploy it next week to check it on Kubernetes.
Yeah, we could do that. I only used the one-click installer, but it would be interesting to combine the knowledge of what we've learned thus far and maybe, yeah. But I think, no, we need to learn about users in RBAC.
We could go with one admin user so that we have currently one fast admin. It would be fine.
Yeah, I think we need elevated permissions.
Yeah, but Hemshot will do most of the job. So, yeah, but we can decide on that.
It would be interesting to provision it or to use it, and then to use, for example, CI/CD pipelines to install something with a Helm chart or something else.
Yeah, but that would be at least 2 sessions, I would say.
Yeah, probably we should extend to 24/7.
Doing live streams only. Yeah.
I don't know how long a live stream on YouTube can last.
I think very long.
Yeah. That's not the problem.
Yeah, if we should wrap it up sooner, then just let me know.
No, I just want to getting things done. What else is missing for understanding the ingress controller? I think I get it now. I just need to redo it on my own.
Yeah. So the next step, now that we have a DNS entry for it, I now have a DNS record for wildcard. Everyone can contribute .photolalai.com to forward to this IP address. Right now it tells us it's insecure because we don't have a certificate yet. So the next step would be to set up Cert Manager to get an automated SSL certificate from Let's Encrypt. We could do this now. We don't have to do it now.
It sounds like a 2-minute step.
Yeah, probably more like 10, but we can do it. All right,
yeah,
then
I
will just go ahead. All right. All right. So Cert Manager. There's also a nice documentation page for Cert Manager, which I will skip a little bit now. But if you want to check it out, just look up certmanager.io. And it's the standard software to manage SSL certificates in Kubernetes. So we will go back to our shell. We will create a nice new namespace. All right, so again, we have to add a repository to our Helm. In this case, it's called JetStack, which is the company developing Cert Manager. And then we have to do something new. We have to install something called custom resource definitions, or often called CRDs. So if we do something like kubectl get pods, then the object type, the kind pods, is known by Kubernetes by default. What is, for example, not known is kubectl get certificates. This should produce an error.
What cert?
Sorry?
You can also write cert. It's the same. It's a short.
Oh, okay. Okay. All right. Yeah, thanks. And the server doesn't have a resource type certificates. So what we are going to do is extend the API of Kubernetes. And let's just accept this for now. We just applied some magic YAML files, and now we can query certificates. There are no certificates yet, but now the API server of Kubernetes understands a few new objects. One of them is certificates, another is certificate requests, or cluster issuer, or challenges, or issuer, or orders. We don't have to take care of all of those things right now. Most of it is relevant for Cert Manager itself. So next thing, we are going to install the Cert Manager. Again, with Helm, it will now render a bunch of YAML files. And then let's see. Yeah, we now have 3 pods running. One of them is Cert Manager. The other 2 are also part of Cert Manager. So if you are not familiar with Let's Encrypt, Let's Encrypt is one of the best things that happened to the internet in a long time. It's a free CA, certificate authority, that provides you SSL certificates. The only thing you need to do is to prove to Let's Encrypt that you are the owner of a specific domain, and then they will give you a certificate to handle encrypted traffic. And before Let's Encrypt existed, this was expensive as hell, and therefore a lot of websites did not support SSL and were terribly insecure. So Let's Encrypt is very, very good, and it's a non-profit organization, and very, very nice, very good part of the internet.
Also, there's currently also a second new free SSL ACME that you can get. So there's also 0 SSL.
Oh, nice. I didn't know this. All right. So for Let's Encrypt, we need something called an issuer, and which is kind of the account. We will create kind of Let's Encrypt account to ask for a certificate. And now this is new. One of the CRDs we just applied, it's API version Cert Manager version 1 now, and kind cluster issuer. We will give it a name, Let's Encrypt. We will have to provide an email address 30 days before the certificate expires. Let's Encrypt will write me an email about it. We will have to define to what server we want to talk to. In this case, it's the production signing server of Let's Encrypt. And we have to tell how our challenges are solved. When we ask Let's Encrypt for a certificate, they will give us a challenge which we need to solve to prove that we own this domain. And it's possible to do this via HTTP, and it's possible to do this via DNS. And we will do this via HTTP, and we will tell our Cert Manager that it please should use the an nginx ingress controller running in our cluster. Or, well, to be specific, we only tell it there's an ingress controller running which uses a class nginx, and that's all it needs to do everything in a way that the ingress controller can answer those HTTP challenges. Basically, Let's Encrypt will give us a string, a random string, and we will serve this string from our domain, and then Let's Encrypt will believe that we control this domain and give us our certificate. And all those things are done by Cert Manager. All right, so we have this issuer.
Yeah.
Yeah, go on.
No, I posted also the link to the RFC literally, where everything is explained how the whole stuff of Let's Encrypt is working. So it's a protocol, it's called ACME. And when you go, for example, to the HTTP challenge, going down a little bit, so that's the main further to in between for, yeah. And currently, when you currently see here's the flow how it works. So literally, like you said, yeah, a token will be generated by the ACME server. And the ACME server afterwards tries to do an HTTP request to the requesting server. So when you go down a little bit, it will use a specific path. So it will use /well-known. Well-known is mostly in the internet for private stuff of the website. And then acme.challenge, and there's the token literally exposed. And you need to respond within 200. This is how it works on a detailed level mostly. Yeah, and it's a really interesting paper. So probably it's not a paper, it's like, there are a lot of other tools also on premise environments. You can also use this ACME protocol to automate your whole SSL insurance if you go to a self-signed way mostly.
Yeah, nice, thanks. Yeah, so I think about an hour ago in the beginning, I mentioned the concept of an ingress controller and of ingress objects in our cluster. So now we have a running ingress controller, we have a running Cert Manager. Now it's finally time to create an ingress to expose something from our cluster. And for this, I want to deploy a bit of an Hello World application. We are going to use this Hello Kubernetes application, which is a nice looking demo which displays which pod answered a request. And here's a nice YAML snippet for this. Right, so at first we have a service. We are not using a load balancer service because we don't want a load balancer. Our load balancer is our nginx ingress controller. We just want an internal service for this. Then we have this deployment, which uses the Hello Kubernetes image. And we can provide a custom message. For example, everyone can contribute. How many typos did I do? Everyone can contribute. All right. So
mostly, can you write back to the service at least the type? So it would be by default when you don't set anything, it would be set to cluster IP. So it's more intuitive for the user. And what probably also explain what a cluster IP is instead of a load balancer.
Yeah, you feel free to explain why I apply this.
Yeah, literally, we don't use a load balancer. That means when we would use the type load balancer, it would mean that we, like we saw before already, that a real load balancer on Hetzner will be created. But currently, we want to route load balancing only internally in the Kubernetes cluster. So for that, there are internal load balancers, and they are called cluster IPs. But because the big problem of our pod is when a pod dies, literally, every time he gets a new IP address. But for example, for the ingress, he can't recognize all the IP addresses. So for that case, he will ask the service that has a stable IP address. So when you check it, literally, you can see it will every time uses like Max already also explained before, it will use the 10, 43, 220, 78 instead of going to all the pod IP addresses. So when you all white, we would also see the internal IP addresses, I think, by the kubectl reports. There should be also a record. Yeah, you can see. So it doesn't use the 42 IP address. It will use directly, the ingress will use only the 43 IP address space. And it's also important that there are separate spaces. Cluster IPs are in a separate space like the pod IP address spaces. Yeah. It's like It's a software load balancer in place. So it uses IP tables like we also saw last week to manage all the stuff. But you can also change this to a more advanced way.
Yeah, that's a crazy part. You can change almost all things and replace them with other components.
Yeah, like what we currently here see is that Kubernetes is not a tool that we are currently using. It's more like a framework for building something. So it's like we can build our own platform that we want to have and use it for our use case instead of that we use to some products, and you can extend it like you want. So like writing your own custom CIDs and writing your own controllers for special workloads that you have, everything is in place for that. Out of the box mostly.
Yeah.
But you need to do it.
So for me to learn, the customized message has a load balancer. We don't use that. And the cluster IP address from Hetzner is what we exposed earlier.
No, we exposed earlier the load balancer. So that's the real IP address. So when you checking the ingress again, yeah, it makes more sense. So you see the type is different. So a cluster IP doesn't have an external IP address. It's only for internal Kubernetes networking.
Ah, okay.
So that you don't go the whole round trip out of your cluster and going back in. It makes no sense. It's right, and for that it's using IPVS under the hood.
Okay, but the load balancer type.
The type load balancer, what it does, if you describe the load balancer again, probably we can see the event, what's currently happening. Like repeating this from last week.
But I thought we have a load balancer in Hetzner Cloud.
Yeah, that's the reason. So because we you can see the events is mostly important. Because when we're using a Kubernetes service like load balancer, the controller takes this service and asks Hetzner to spin up us a real load balancer on Hetzner against the API. So a cluster IP doesn't do this at all. It's only there. So there are no events when we would probably check the there we should also see the reconciliation loop and wait when the object is happening and should
For example, here.
Yeah.
Okay, so the ingress controller is acting as the load balancer, and there are no other load balancers like created in Hetzner Cloud, saving us costs. This was the idea from last week.
Yeah, that's true. And now coming to the big important point. So the difference between the service load balancer and our ingress controller is a service load balancer is only on layer 4. So it's only TCP IP. It's nothing special. But if you want to do an HTTP request, we're going in the OSI layer higher. So it would be layer 7. It could be also some different protocols. It doesn't need to be HTTP. But on that, then we want to serve only about, for example, want to enter an URL. So we don't need to enter an IP address and all the stuff. And that's the reason why we have a load after the load balancer, the ingress controller mostly. So because we're going from layer 4 to layer 7 in the OSI model.
Okay, but where is the load balancer? Is this the Hetzner resource?
It's a real Hetzner load balancer. So we're asking for
each time we create a service of type load balancer, when we really have literally the word load balancer in here, then the cloud controller manager will always create a matching ingress, matching load balancer in Hetzner Cloud. So it's a one-to-one connection between the object here and the load balancer service in our cluster. And each other service of type cluster IP, it's also kind of a load balancer, but it's not a public load balancer. It's internal in the cluster. Like behind the service could be several pods. That's why it's an internal load balancer.
Can you check now again the endpoints of our new deployment of our new workload? So then probably then we can also see it. I hope so. It's more intuitive then. Because we did so. or kubectl.ep is the same. And we would get all the endpoints. Yeah. So really what you can see here now, we can see the same service currently has the IP address 43, and currently the service has also multiple endpoints, and these are the real IP addresses of the pods.
Mm-hmm. Yeah, that's only internal to the cluster.
Yeah, only for internal, and because the ingress controller, the nginx is also in the cluster, but also from the front side, it's exposed publicly with a real IP address. But all the communication from the ingress controller will only be done by the internal IP addresses.
You, Max, had the network traffic flow description text editor thing.
Yes, I think it's still here somewhere. Here, yeah.
Yeah, okay.
So
this service is the load balancer service.
mm-hmm.
And back here, what the ingress controller will use is the cluster IP service.
And then
Okay,
we'll
this acts basically as a management daemon or management thing, assigning it correctly, or like routing the traffic correctly. Actually.
Yeah, mostly load balancing.
Yeah, I think I have a different understanding of load balancing, or I kind of confused it. So I'll keep asking lots of questions.
Yes, please ask all the time. That's why we do this. All right, so the last part missing now is the connection between the ingress controller and our new service, right? The ingress controller is not aware of it yet. So we go back to our demo here, and now we create this magical ingress object I told you earlier about. And for a second, I will also open the documentation about it again. So, because if you want to learn more about it, you will definitely have to go to this page, and there's this example how an ingress resource looks like, and then a bunch of explanations what the different options are and everything. If you ever configured a web server, then you will find the same patterns in here. Like in Apache, you have virtual hosts, and in our ingress resource, we have a host, which is very, very similar. And then we have different, for example, in nginx, I think it's then called a location. Then this is, which is a path in an ingress resource.
Yeah,
so
the backend is mostly the upstream of an nginx. So because
exactly.
nginx or all ingress object doesn't allow us to set it only to specific pods, because it could be the failure that a pod could fail, and we want to do load balancing. So we are only allowed to name a service to route the traffic to that. So that means that we need to route it down. Yeah, probably we can deploy it now.
Yeah. So let's apply this. Now we see the service deployment are unchanged, but the ingress is now created.
Can you show me the configuration, the YAML again for a moment?
Yes.
I would like to take a screenshot. Thank you.
And so now you have, a few seconds ago, there was no address. Now there's an IP address. And if we look in our ingress namespace at the services again, then you can see that it's exactly the same IP address like our load balancer service. It's the public IP address of our Hetzner cloud load balancer. So this is here now because our ingress controller now picked up this ingress resource and used it to configure itself, and also wrote back to it that it's exposed with this IP address. So earlier I already configured a DNS entry to this. So let's look in the browser. I think over here. It's still no SSL yet, so there's a little interesting hack in Chrome. You can now type, "This is unsafe," and then it reloads and completely ignores. No, let me try again. And yeah, it completely ignores all the security features that are supposed to block it from accessing this page. So now we can see this demo application that we have running in 3 different pods, still without HTTPS. And if we refresh the page a few times, we can see that the pod name here changes. So each time our traffic hits the ingress controller decides randomly which backend is used. That's why our traffic is served by different pods. So that's already nice. We can see our custom message here. And now we need to switch on SSL. And therefore, we are going to add a few settings to our ingress. One of them is the TLS section. It feels a little bit redundant, but this one is for the web server configuration, and this is for the SSL configuration. We have to do it in both places. And then we also add an annotation. That annotation is necessary for the cert manager, because the cert manager will also monitor all the ingress objects. And if it sees an ingress with an annotation like this, then it will use the cluster issuer with this name to create an SSL certificate. So earlier we created this issuer called Let's Encrypt. That's the mapping there. And let's apply this again. So now our ingress was reconfigured. And now what we can do is kubectl get pods, and now we see there's a new pod. This one was created by our cert manager. And we also have a new ingress for a few seconds, no? Because there's this ingress which was created by cert manager. Now cert manager created this ingress, and now the ingress controller again will pick up this ingress and configure itself to serve. Okay, now it's already gone, but to serve this pod, yeah, also under this host name. And then Let's Encrypt queries our domain, and this pod answers the challenge, and therefore proves that we own this domain. So by now we should be able to run kubectl get certificates.
That's really nice, by the way, because I really struggled with integrating Let's Encrypt into my Docker Compose container setup. Doesn't work.
Yeah.
Or it works, but the renewal doesn't work for some reason.
Yeah, I think this cert manager alone justifies to replace a Docker Compose setup with a single node K3s setup, just because you get the Kubernetes API and all this stuff almost for free.
Yeah, because
yeah.
So I'm running the everyone can contribute.dev page, and this is a Docker Compose whatever thing with Let's Encrypt, and it doesn't work. And you got me an idea. Thanks.
Yeah, you're welcome. And now Cert Manager created the certificate for us. It's now officially signed by Let's Encrypt. It's valid for 90 days, and 30 days before it expires, the Cert Manager will take care of extending it. So let's go back to our website. I think I need to open it in a new tab for Chrome to realize. Yeah, now it's not red and unsecure here anymore. Instead, our connection is secure. we have the valid certificate from Let's Encrypt, valid until May this year. And still, each time we refresh it, we get a different backend here, like a minute ago. So yeah, that's the whole chain of things to do to expose this ingress. So the nice thing now that we have this ingress controller is that we can use it to expose as many HTTP websites as we want. So all we need to do is create additional ingress, for example. It uses a little bit of a different domain, not hello, instead it's world. And down here, we use the same configuration for the backend. But if you have a more complex application and we could define, I don't know, the admin backend, for example, is running in a different service, for example, then we could use this here. And the ingress controller would automatically configure itself to match this configuration. So if you apply it again, oh, sorry, I think I copied something wrong here. Yeah. All right, so now again, we have this ingress, we have this challenge ingress. And if we wait a moment, for example, we should get a new certificate. We already have the new one, but it's still in the state ready false. We can, for example, also see that there is a pending certificate request. I think now it's done. Yeah, now both are ready. So, for example, if the certificate never switches to true, then it is a good idea to check the certificate request, which is a little bit of under the hood magic of Cert Manager. So now we should be able to go to this website as well. And it works. It also has a valid certificate. And now we can do this with as many domains as we want to. And this is very nice because if we operate a Kubernetes cluster and our coworkers or friends want to publish some websites in it, we can provide them with one single ingress controller, which is all running behind the same IP address, one load balancer of our cloud provider, and then the ingress controller takes care of sending the traffic to the right backend and taking care of all the certificates with the Cert Manager. Yeah, that's it.
So I want to build a Hetzner or whatever. Probably doesn't matter where it runs, but a Kubernetes cluster in a cloud and sponsor the everyone can contribute.dev domain, and then everyone can like deploy something from GitLab to this thing. This would be interesting. But we need to so I cannot speak English today. We need to sign off for today, I think, or we need to find the finish line for today, I think.
Yeah. Yesterday when I prepared today, I really tried to leave stuff out, and it's still too much.
No, it's not your fault. I think it's a learning curve. I think I didn't understand everything, but I asked a lot. And my problem or my blocking point with Kubernetes always was it was too much, and I didn't have time for 10-hour courses or lectures. And I'm learning by example. And you're giving me like the best examples I have, so I can ask you as my trainer, my personal trainer. Yeah. So I'm really thankful for all you do and help us dive into the magic stuff of Kubernetes and also Hetzner Cloud, of course.
Yeah.
Is there anything else we need before we wrap up? What's
no, I think
coming next week?
Not entirely sure. I guess we have to check with Niklas. Maybe he wants to prepare stuff for the user management and permissions for next week.
I can do. So should we can use GitLab for that. So we can use GitLab as a GitLab user. I can log in into the cluster. So we can use OpenID. I can also explain a bit how OpenID is working, and then we would use DEX, I think, for that. But I will figure out how we can do that.
What I want to do, and we can do this, or we should do is do this asynchronously. I want to create a Hetzner group in my account, so we can play around, and I expense everything, which we kind of do, and find a way to. I think I can just add your account if you provide me with the account in a group.
Yeah, you can just add us to a group.
Yeah, I can add you to a group, and then you can we are working on the GitLab repository or the GitLab group, and on the Hetzner Cloud group, and I think it should be fine, and we can recreate what Max created before in the demo, and yeah, this should be working. If I haven't done this by Friday, Nicholas, please ping me.
Or I wrote me a reminder. I forgot it, so just okay.
A reminder to remind him.
Yeah.
Yeah, it's the
So
typical thing of time.
If it didn't happen until Saturday, I will ping Nicholas to ping Michael.
Okay, and who else? Michael Altner, who's not here today, will ping someone on Sunday. Okay, yeah, that's great. Anything else? Where do you user management next week? And then afterwards, we have many different ideas. Yeah, looking forward to that. Next week, we can do 6 p.m. again, if it's possible for everyone.
I'm just checking my calendar, but
if I'm not doing something special, I think yes. But I will inform early enough, so if I see it on Monday or something like that, it should in my week.
If it makes sense, we can also stick with 7, but I'm not sure about it because it's like family time, at least in Europe.
No, for me, 6 p.m. is okay.
Or beach time for some people.
Yeah, for some people. I know where you're at, so I will use my Google Map, Zoom, and stalk you.
Probably yeah, it's fine.
Okay, then if we have anything else, we can sync async. Sounds strange. Connect async, and yeah, thanks for the nice session. And I want to say bye-bye on YouTube.
Yeah.